Okay, we have one theorem that we talked about in 8.1 already, where when we have this situation with a right triangle that has an altitude going to the hypotenuse, that we have three similar right triangles. Now keep in mind, if your figure maybe looks like this, I will rotate my paper just so that I always have that longest hypotenuse kind of horizontally. Just easier for me to see the relationships. Okay, so the first corollary that we're going to look at, I'll show you why this works, but I'm going to show you the relationships first. We've talked about the geometric mean, and so one relationship that always works, I will start from the very left-hand side right here, and I'll say C is to E as, and then I'll go down, E is to D. And it kind of makes an upside down T. So I'm going to do it all together. C is to E as E is to D. Now notice you have a geometric mean. Every one of these relationships will have a geometric mean. And the reason this works is, I'm going to erase these. For instance, let's say we draw these separately. So I'm going to look at this right triangle on the left, right here. If I'm to draw that separately, I've got my hypotenuse, looks like it's A, the shortest side looks like it's E, and the middle side looks like it's C. And then let's take the right triangle on the right. It's already the same orientation. And I usually draw them where they're oriented the same exact way. So the hypotenuse looks like it's B, the shortest side looks like it's D, and that middle side looks like it's E. So the reason this is true, remember, with similar triangles is that our sides are proportional. So we've already talked about in 8.1 how these triangles are similar. So we can say C is to E as E is to D. And so that's why that relationship works. But I always think of that upside down T starting from the left side. C is to E as E is to D. That's your first relationship. Okay, now I'm going to tell you the second relationship. And the second corollary actually has both relationships listed together. So this time I like to start from the inside. I always start from the inside. And I go to the left. I say C is to A. So I'll write that down. C is to A. As A is to the whole hypotenuse. So that would be A is to C plus D. Notice the other relationship that I wrote has a geometric mean. If you write a relationship that doesn't have a geometric mean, that should kind of tell you you're not writing a correct relationship. Now the reason this is true, let's look at this big triangle. And what I'm going to do is I'm going to orient it the exact same way as those other triangles. So it looks to me that the hypotenuse is C plus D. It looks to me that the shortest side is B, and then that middle side is A. So I'm going to erase some of these markings that I had earlier, just so that there's not so many markings going on. So we can say, let's see here, I need to fill these back in. So I can say C is to A as A is to C plus D. So that's why that second relationship works. Okay, and then we have a third relationship. It's very similar. If you remember, we started from that middle. I'm going to erase these just so I can start over. So remember how we started from the middle? This time, instead of going to the left side, we're going to go to the right. So you can say D is to B as B is to the whole hypotenuse. Well, the whole hypotenuse there is C plus D again. Notice for the third time, I wrote a proportion where I have a geometric mean. So in all three of these relationships, just make sure the reason that they work are because the sides are proportional. But ultimately, make sure that you're writing a proportion where you have the geometric mean. And if you need to, I would orient your triangles just like we did here. So notice they're all oriented the same way. And so for those of you that are visual, this will help you. Okay.